Exactly. Thank you for the introduction. My name is Paul Reichardt. I want to introduce our paper, a brief introduction to deploy Amazon Web Services for online discrete event simulation. The paper was written by Mr. Vladimir Hoffmann, Sebastian Lang, Tobias Regelin, and myself, Paul Reichardt, and we are all affiliated to the Otto von Guericke University in Magdeburg. This is my agenda for the next 10 to 15 minutes. I want to give a short overview about the motivation and the scenario. After that, I want to introduce our concept. And third, I want to speak about the implementation and provide a short demo. So the motivation. Of course, digital shadow is a big thing in the industry because real-time or real assets, production assets, produce real-time data, and those can be transferred to simulation models. This is called a digital shadow, and those simulation models allow us to get operational insights and to create forecasts. The basic idea for the paper came from the PhD thesis of Toni Donhauser. It is linked here, but you also find the link in the paper. And this PhD thesis focused on simulation-based order scheduling based on order data. And what Mr. Donhauser did was that he used Siemens plant simulation plus several other commercial applications to create and to run a simulation and to provide data according to how the production works and what possible influences and delays, for example, could be. So this was the motivation, and what was our idea about that? Is that possible to build something like Toni Donhauser did with an open source software and managed with a cloud solution or with cloud services to get computing power and not to use expensive or not to have expensive assets on your own. For this, we created a very, very simple scenario containing of those 7 steps. The scenario starts, of course, with the production order. After that, the order is put in the system and material is ordered for the production order. The 4th step is that the order has to wait for the full material the full availability of material. After that, the order has to wait for the production asset because it's just a single machine. So there's just a capacity of 1 in the production. So whenever an order is in the production already, it has to wait. The 6th step is the production, of course, and after that, the order can be delivered to the customer. So this is the very, very simple scenario that we looked at. And our goal was to forecast deviations caused by delays during the material delivery. So more or less up here between the steps number 3 and number 4. So, and what was our concept? What does it look like? It basically contains of 7 steps. So, of course, step number 1 is we looked at the real production asset, the client, as the data producer. After that, there's a big block of the event analytics pipeline. It contains of 2 major steps. On the one hand, the event tracking. So to take the information from the real production asset to put it in a database and afterward provide it to the simulation. And at the very end, the visualization. But now I want to speak about the steps more in detail. So step number 2 contains the service AWS Kinesis. It is used to keep or to manage the data from the actual production asset. For example, to queue the information in line and to keep their proper queue. After that, the service Lambda is used to ingest or to put the information or the data in a database. Fourth step is the state database. This is the database where all the different states have to be kept. And from this database, another service, so again, Lambda service, is used for the event analytics and the actual simulation, and all the changes or the simulation results are put in the forecast database. Both databases based on also an AWS service, Dynamo OS. And basically what the seventh step does, the dashboard, is just to visualize the changes that are created in the forecast database. Yeah, this is roughly the concept. And now we want to have a more detailed look about on the implementation. What does the implementation look like? It is Python based, and we use the library SymPy and the graphical user interface Casimda. Of course, like for other simulation models as well, it needs a kind of a work in process initialization to create a steady state simulation. AWS cloud services are used more or less for everything, at least if the simulation is run. So for management, computation, and for storage, as I said earlier, so all the services are provided by Amazon or Amazon Web Services. The infrastructure for the configuration of the AWS services is done with the application Terraform, and Docker and local stack are used for containerization and the emulation of the services during the local development. Because what you have to keep in mind is you pay the Amazon Web Services per use, and that's why you don't want to pay them if you don't really run the simulation. And especially during the development, you don't want to pay all the time. And that's why local stack is a very useful application to emulate the Amazon services. So to emulate that they are available instead of paying them. For everybody who's interested, you can have a look in Vladimir's or in our public GitHub repository, but it is referenced in the paper as well. So this is the implementation. Now we have a short look about on the code. First step is, as I already said, local stack is used to start a local AWS service, so without paying Amazon. After that, the two Lambda services are implemented, one for the ingestion and the other one for the simulation. Third, the configuration of the services is necessary. Here for Terraform is used. And the last step is the visualization. So the information from the forecast database are visualized in a dashboard. Here we provided a short, I have to start at the start, of course, a short video where you can see how it works. So at the left, you see our very simple scenario, and on the right, you see the dashboard. So the first order starts, has to wait for material, has to wait for the start of production, and is produced. Second order starts, the material delivery is delayed. That's why the third order has to queue in line. And you see the fourth order is late as well, but the fourth order has to wait for material too. And that's why it does not have to queue for the production. can look at it again because it might be a bit fast. First order, second order, wait for material, third order has to wait for the production asset, and fourth order has to wait for the material again. Yeah, this is more or less how it works. And yeah, now a short conclusion. So the pipeline model, so the 7 steps, they work for cloud-based digital shadow application. So this was our use case and it was successful. Yeah, the open source implementation does also work for very simple operational forecasts. In the near future, or as a next step, more complex use cases should be implemented, more orders, and of course, more production assets, so that more machines, more production lines, and so on. And of course, in the simulation, different decisions or different alternatives should have be evaluated, because this is kind of the big advantage that the simulation offers to handle upcoming problems or possible delays. And of course, using cloud services, security is always an issue. So security aspects should be kept in mind as well. And yeah, Amazon or Amazon Web Services is really just an example. So all those services, or very similar ones, are provided by Google, for example, or by Microsoft as well. So this was really just a first example, and we used Amazon just because it's the biggest provider at the moment. Yeah. This was my short presentation. Thank you very much. As I said earlier, you find the GitHub repository and the little blog post of Vladimir Hoffmann, open access. Yeah, and now I'm interested or open to your questions. Thank you.
Thank you, Paul.